Open Desmos and then you click on the plus. We want to enter a table of values and there it is. And then you just go ahead and enter the numbers that you've got. X was the independent variable, right? This was the diameter. And then the circumference was the y. It depends upon the size of the diameter. Okay, so you go ahead and enter that. I've got a little shortcut. I've already made some numbers, so I can copy this, go to Desmos, and actually you can just click and paste the whole table in. And there you go. That looks quite nice, right? And then maybe I'm going to add one more value. If we had a circle with a radius of 0, can you think what the actual, diameter of 0, my bad. Can you think that the actual circumference will also be 0? Does that make sense? Because its circle wouldn't exist. So this looks to be maybe a straight line through the origin. I think if you remember back to a previous unit on rates and proportion, this could be a direct proportion graph. So a direct proportion graph means that we can model it by y equals k times by x. All right, y equals k times by x. And I'm going to add a slider here. And look what happens as I make this y equals 1.4x, y equals 1.7x. Here's y equals 2.3x. Let's go up to y equals 3x, not quite. Y equals 3.3x, too much. And look, that looks pretty good, right? Between 3.1 and 3.2. So that's just kind of having a best guess. So y equals 3.1x is a pretty good model. And that seems to be quite good, right? This 3.1 is the gradient of the line, okay? But now we can ask Desmos to fit the best model through. You'll need the keyboard on Desmos for this. And then you go ahead and type. Now look, our y1 values here represent the circumference. So y1, I want to be modelled by, so we want the rule to find y1, the circumference, if we know the diameter. Okay, so click on ABC, and then there's this little guy tilde on the bottom toolbar. So we say fit the best model for y1 linked to, and I'm going to put m for multiplier times by x1. And ooh, look at this. You see the red line? Can you see the red line compared? I'll just zoom out a bit. So the red line compared to the blue line doesn't seem much difference. But if you look down here, it's telling me that the m is 3.14. So actually circumference seems to be 3.14 times by diameter. We had a best guess at 3.1. Actually 3.14 looks better. And if I actually zoom in on this graph at the top here, I'll just keep zooming in. Oh look, you can see, can't you? Look. So the purple or the blue graph is 3.1 times by the diameter, and the red graph is 3.14 times the diameter. So it seems that we can get the circumference of any circle by taking its diameter and multiplying by 3.14. And indeed, that is the relationship we're looking for.